In this session, I'm going to explain about the two major secondary structures, beta pleated sheet and loops. First, beta pleated sheet. Main chains, they just localized next each other. Main chains, they just making, as you see here, some pleat shape, peptide bond, and one strand, a peptide bond in another strand. They are making planes. And the following stuff, peptide bonds, they also single planes together, but with certain angles, and etc. So main chains, they just making pleated shape in the structure. This is the side view, single main chain, peptide bond, peptide bond, peptide bond, peptide bond. You know, the other strand stack over or below this one. Okay. So, and the pink color representing side chains, they just alternate from right to the right side and left side, right side, and left side, something like that. You see the overall direction of this peptide N to C from top to bottom. This is top view for this stacked the beta pleated sheet. By the ball and stick model, this is by using the atom formula. So there is some again hydrogen bonds between NH and CO from the two different strands contribute to make these things. This is clearly shows you how where the side chains are positioned in pleated main chain, going down and up, all together. But please notice that two strands are going in opposite direction. First one from top to bottom, N to C, but in this case C to N, something like that. So anti-parallel. This is another view for the anti-parallel. Equally, parallel shapes also possible. As you see, all strands, they just oriented to the same direction, N to C, from top to bottom. As you see in C structure, again, the overall structures are very similar to parallel, anti-parallel beta pleated sheet. Main chains just pleated sheet, while the side chains in pink color, they just alternate up and down, up, something like that. you can see again the hydrogen bond made between two strands peptide bonds. It's very similar to antiparallel. This is a space filling model for antiparallel beta sheet. So it's kind of spread type. Here I summarized the features of a beta pleated sheet. So N is going to be 2, P is going to be about 7 angstrom. So there are 2 residues per turn, so it's going to be 3.4 exactly angstrom per residue. Again, hydrogen bonds is made by CO in one strand in this case and NH in the other strand. There are 2 types, parallel and antiparallel. Side chains, they are alternate up and down. Again, purine is not compatible in this structure. Usually 5 to 10 long the stretch is popular. It also slightly right-handed twist. Next, loops, also called reverse turn. For example, as you see here, anti-parallel beta pleated sheet, but they are connected by sharply the turning structure. This region is called loop. Okay. So especially the loop connecting beta pleated sheet is called hairpin loop. Okay, depend on its actual conformation. There are 2 types, type 1 and 2. But the loop are really very varied for their structures, meaning there are so many different types possible found in actual proteins. Often they are very functional loop regions. This is just a big looking omega, so-called omega loop. There is some variant type.